This year's Everything Procedural Conference, I don't think I was the only one that was blown away by the student showcase this year. There was loads of amazing work on display, and one of the projects in particular jumped out at me. It was a castle wall generator created by Seb van der Beemt. He's a student in his second year at the Creative Media and Games Technology course at Breda University, and he's on the lookout for an internship in the area kind of technical art, Houdini, Python scripting, Unreal Engine, all that good stuff. And I asked him if he'd be willing to produce a video for this channel, sort of going through a similar tool to the one that he showed off at the Everything Procedural Conference, and he kindly agreed. So without any further ado, I'm going to pass it over to Seb, and he's going to walk you through a somewhat simpler scriptable tool in Unreal that leverages Houdini engine to make a really nice kind of user experience around editor time tools.
Hello everyone, today I will be showing you how you can use scriptable tools and blueprints in an Unreal engine to create a better interaction of your Houdini assets in Unreal. So the tool we will be building today is this fence builder tool. You can click the icon, and then in the viewport I can basically just click and it will draw out a fence for me. I also spawned these handles that allow me to really easily change the shape of the fence. There are some settings you can change to change the look of the fence, and I will also show you how you can swap out the meshes like this. And as a little comparison, I also would like to show you what the HDA looks like by itself. So if I grab it like this, I have to drag it into the scene. I have to scroll down, I have to give it a curve, and I need to feed it my landscape. I need to start selection, use current. As that's not the only bit, I also need to feed it my meshes. So the way I usually do this is by finding my mesh, right click, copy the reference, and I have to paste it in like this. So I have both meshes for like a plank and a wooden pole. Like this. I also have some settings to change the height. I think it's better like this. And there's also my curve points. You can track it out. Also have a settings to change the spacing between the fences a bit, because as you can see some planks are floating. So I have to change the spacing. This looks a lot better. And in general, this is a very tedious process and it takes much longer to create a fence than the tool I just showed you. So before I start to show you how we can make it, I would like to point out that it is handy if you already know a bit about blueprinting. And it's also handy if you already know a bit about how Houdini engine works. Before I start the tutorial, I would also like to give a shout out to Samira Evers. She's the one who initially introduced me to this topic. And a lot of the techniques I'm about to show you, I also learned from her. So let's get into it. So the scene I'm in right now, you can find that in the description of this video. However, if you are in a custom scene, you do need to enable a few plugins. So if you go to Edit, Plugins, you want to enable the Geometry Script plugin. You want to enable the PCG Geometry Script Interrupt plugin. And most importantly, you need to enable the Scriptable Tools plugins. So that's Scriptable Tools Editor Mode and Scriptable Tools Framework. If you do download the scene though, you will also be able to find the finished version of the Scriptable Tools we're going to be creating today. It's fully commented out, and you can maybe use it as like a point of reference if you get stuck somewhere. However, I'm going to create blueprints from scratch now though, so I have this empty folder right here. And I am gonna first start off by creating a new blueprint. I'm going to go down to Editor Utilities and say Editor Utility Blueprint. I'm gonna type in Scriptable, and I want to select Editor Scriptable Single Click Tool. So I'm gonna select this one, I'm gonna say BP underscore, let's say tutorial fence. I'm going to open it up. And if you open it up, you can see the scriptable tool settings to the right here. So we can give it a name, let's say just tutorial. The long name is, let's say tutorial fence. Category, the category is this little drop down right here. So I must say Houdini assets. And if I hit compile and save right now, you will see that when we refresh the scriptable tools window, a new icon has popped up for tutorial. So this is going to be our tool. However, if I open it up, we don't have an interface yet. So let's open the final one. You can see we have input field for the number of planks. So let's draw out a fence real quick. The number of planks, to change the number of planks. We have a boolean that flips the fence. And we have the two meshes the tool is using. So let's replicate this interface. To do that, we need to add a new blueprint. So I'm gonna go right click, go to edit utilities again, and say scriptable. And then we're gonna want to go for this one, editor scriptable interactive tool property set. And what a property set is, it's basically the thing that holds your interface. So I'm gonna call it BP tutorial fence interface. Let's open it up. Let's put it together with this window. There we are. And I am going to create a bunch of variables that represent my input fields. So as we saw earlier, we have an integer for the number of planks. So I'm going to create an integer variable called num_planks. Let's set this to integer. I have a boolean for the flip fence. So let's create a new one called flip fence and set it to boolean. Also, don't forget to toggle this little eye icon to make it visible. There's also pull mesh, which is represented by a static mesh. So let's say pull mesh, then look up static mesh, make it visible, and then there's blank mesh. So let's say blank mesh, it's already a static mesh, and let's make it visible. If I compile and save, I can also set my default values. So for the number of planks, let's say our default value is 3. I think for flip fence it's alright if it's unchecked. Pull mesh, let's say wooden pull. For plank mesh, let's say wooden plank. Now if I select my tool, you'll see it still doesn't work, and that's because I haven't told my tool yet to look at this blueprint for the interface. So let's do that next. So if I open my blueprint, I'm going to add a new function. So if I hover over this functions tab, I get this drop down. I'm going to select on script setup. What this means is it basically executes the moment it launches the tool. So I'm going to drag a new node. Let's say add property set of type. The property set type is the blueprint we just created. So BP tutorial fence interface. Let's compile and save. And now you see we have our little interface. Cool. One small thing I want to change though is, let's say I change the number of planks to 2, enable flip fence. If I complete and start my tool again, it resorts to my default values. But I do prefer it to use the values I set previously. So what I need to happen is basically before I close my tool, I wanted to save my settings and reload those settings the next time I open my tool again. So to do that, I'm going to restore property set settings. I'm going to drag this in here, and before I close, so I need a new function for that, on script shutdown. So this gets executed when the script is shutting down. I want to save my property set. So I'm going to say save property set settings. So I need to give it my property set. So let's just create a variable, say property set. I'm gonna get it. I need to give it a save key. So let's say tutorial fence, which is basically just the identifier for the settings we saved. And now if I hit compile and save, I'm gonna select my tool and I'm gonna change it up a bit, add complete, and now I launch it again. You see it's remembered my settings from the previous time. Awesome. To make it a little bit more readable, I like to just collapse this to a function. So let's say add interface and compile and save. So another thing I need to happen when I launch my tool is that I wanted to add a HDA in my scene, the HDA of the fence builder. So to do that, let's just complete this real quick. To do that, I first want to make sure that I actually have a Houdini session running. So to do that, I can add a node called get Houdini engine public API. I'm gonna drag it off. I'm gonna ask, is the session valid? So do we have a session going on? So if there is no session, I want to create one. And luckily there's also a node for that. So create session. Let's drag it in here. So now we have a session. We can instantiate our Houdini asset. So let's say instantiate asset. So as the name implies, this node just adds an HDA into our scene. We do need to give it a bit more information though. For example, the asset we are actually instantiating. That's the in Houdini asset. So I'm gonna drag this off. I'm gonna promote this to a variable. That's called HDA fence builder. If I get compile and save, I can give it a default value. So let's say HDA fence builder. Compile and save again. I'm also going to give the world context object. So let's say just self, like get a reference to self. And after that, it gives a return value. This basically just represents the HDA we just instantiated. Since we're going to be using this value quite a lot, I'm going to promote this to a variable. And let's say HDA fence builder instance. Awesome. So let's test this out. I'm gonna select my button, and you can see it adds my HDA into the scene. So if I go to the settings, you can see it is using all of the default values that come with the HDA itself, but I don't want that to happen. I wanted to use all of the values from my interface in here after it's done, after I add it in the scene, but I also want it to already set the node inputs. So I wanted to select world input. I wanted to select my landscape. And I'm not gonna do the curve input yet. I'm gonna do that later, but I do want to select my landscape input. Luckily, this can all be automated in blueprints, so I'll show you how to do that next. So first thing I'm gonna do is I'm going to add a node called bind event on post instantiation delegate. So what does this mean? It's basically it allows us to add a custom event that fires the moment the asset is done instantiating. And we need this because it's impossible to set node inputs of our HDA before the asset is done instantiating. So let's give it a name. Let's say set fence input. And we also need to unbind this again. So unbind event post instantiation delegate. And in between these two nodes, we can everything we put in between those nodes gets executed right after the HGA is done instantiating. So since I want to put my landscape into the second input, I will first need to create an empty one. So let's say create empty input. This also gives us a little drop down of what kind of input we want. I want a world input. So we have curve input, geo input, and world input. With that done, I want to set the input objects. So let's say set input object, which takes the input, but it also takes up the objects. And the objects we want to feed it is our landscape. So basically everything that's in this little menu right here. We first need access to the landscape though. So to do that, I'm gonna add a node called get all actors of class. The actor class I want to go for is landscape. Let's promote this to a variable. Say landscape actors. And let's feed this into the input object. So as you might have guessed, this node gets all of the actors that are of landscape class. I have only one landscape in my scene, so this is fine, but it is problematic to send a lot of landscape data to Houdini. It can take quite a bit of time. So you might want to optimize this a bit further, but because as I said, I only have one landscape, so for me this is fine for now. So after we set input objects, we still need to tell Houdini which one of the inputs we are actually using. So as you see, there's two subnetwork inputs. The first one is going to be the curve input. We're going to do that one later. And the second one is our world input with the landscape. This resides at index 0 and this one is at index 1. So to tell Houdini which one to use, we're gonna add a new node. Let's clean this up a bit. And the node we want to call is set input at index. We need to tell which input we are using. So that's this one. And we need to give it an index. So this is going to be 1. So let's hit compulsive. Oh, we still also need to drag this wire into the event. There we are. Let's clean it up a bit, so it's a bit more readable. Compile and save. And let's test it out. So I'm gonna delete this for now. I'm gonna hit my button. And you can see it gets the second input. It sets it to world input and it automatically plugs in my landscape. Awesome. So with that out of the way, I'm going to move on to the parameters next. So as you can see, the number of planks is 4, flip fence is checked on. And I also want to automatically give my pole mesh and my plank mesh. So just like with the node input, we cannot immediately set the parameters of our HGA either. If you go to the Houdini Engine public API website, you can see all of the delegates that we are using or that are out there. And the next one we want to use is the on pre-instantiation delegate. I know it says post on here. I'm pretty sure this is just a typo by side effects, but it's meant to say on pre-instantiation delegate. And if you look at the description, it says broadcast before an HGA is instantiated. The HGA's default parameters are available and can be set. So to do that, I'm gonna drag a new node and let's say bind event on pre-instantiation delegate. Let's unconnect this for now. We're going to connect it back up later. I'm going to drag a new node again. Let's say add custom event. And let's say set node params. The way to set inputs in our HGA is quite straightforward. We can, for example, if we want to say change the number of planks, we can say set int parameter value. It needs the name of the parameter. So if we hover over the number of planks, it says planks amount. So let's type that over. Say planks amount, and it needs the value. Small little problem though, we don't have our values yet. I know we have created the interface, but we don't have access to their values yet. So to do that, I'm gonna create a new function. So let's say collapse to function, get input data. Let's dive in. I'm gonna get my property set. Say get editor property. And it only needs the property name. So if we go back to this blueprint, let's start off with the number of planks. Let's copy paste that. And we can create a variable here. Let's also call it num_planks. Set it to an integer. Set. And now the number of planks from the interface is stored inside of this variable. So let's repeat this for the other ones as well. So I can just copy paste. The next one I want to go for is flip fence. So let's copy paste it. Flip fence. Create a new variable called flip fence. Set it to boolean. Let's just set it. And there we are. Next one I want to do is spool mesh. So let's copy paste. Get editor property. And let's chuck this, let's give it this input. And I'm gonna create a new variable. Let's say spool mesh is going to be of type static mesh. Let's set it. Let's copy paste this again. I'm pretty sure it's called blank mesh. Let's give it blank mesh. Let's create a new variable for blank mesh, and let's set it like this. So now we basically have all of the variables from our interface, and we stored it inside of these variables in our tool. Okay, cool. So I'm going to go back to my sendIntParameterValue node. I'm going to grab my number of planks variable. I'm just gonna give it to the in value. Okay. So now I want to unbind my event again. So I unbind event on pre-instantiation delegate. And then I'm gonna give it this wire. And now we can just test it out, see if it works. So if I click the button again, you can see it updated my planks amount. Awesome. So let's repeat the same thing for all of the other parameters then. I'm also gonna link this back up because otherwise this node never gets executed. Let's give it a bit more space. And let's do the flip fence next. So I'm gonna use a node called set bool parameter value. Let's chuck it in. And then we're gonna get the flip fence variable. And let's give it to the in value. I called this one flip fence as well, so that's the parameter name. So flip fence. Let's hit compile and save. And let's test it out again. Let's see how it works. So I've hit delete the old ones first. And you can see it also set the flip fence parameter. Okay, now we can move on to the pull mesh and the plank mesh then. Let's start off with the pull mesh. It's a string parameter, so the node we will be using is set string parameter value. The name of the parameter is pull mesh. So let's say pull mesh. But right now we cannot just directly drag it in here. We need to get the object path of our pull mesh. So what that means is initially when I have my asset, I would say right click, get copy reference. I would need to plug it in like this, but we can also do this through Blueprint. So to do that, I'm gonna drag a new node and I'm gonna say get asset path string. Oh wait, get object path string. And I'm gonna drag this in here. So let's test it out again. And you see it automatically gave me the asset reference to my pull mesh. What you also saw me doing at the start was, I'll show you right here real quick. What you saw me doing at the start was also adjust the height of the fence based on the height of the pull mesh I feed it. So if I go back and select my plank, copy reference, give it this one right here, you can see that the planks are quite low. So I'm gonna adjust this fence height parameter and you can see it adjusts the height of the plank. So basically what I want to give it is the height of the pull. So to do that, I'm gonna get this node again and I'm gonna say get bounds. Then I'm gonna break the bounds. I'm gonna break the box extent. I'm gonna get my Z component and I'm gonna divide this by 50. So what's happening here is I'm getting the bounding box of my pull. I am dividing it by 50. The reason why I'm doing that is I first need to convert it from Houdini units to Unreal units. And I also need to multiply it by 2 because this node considers the origin of the object to be in the middle. But I want to get the entire height, not just the height from the middle, so I have to multiply it by 2. So divided by 100 and multiplied by 2 can be simplified to divided by 50. So next I should update the fence height parameter. So I need to update this one, the fence height. Let's see what I called it, fence height. Let's say set float parameter value. There we are. Let's drag it off, let's connect it again. And the tuple name is going to be fence height. And the value is going to be the one we just created, this one. So now we can test it out again. So let's add it. And you can see it did the fence height. Cool. Now we can actually just repeat the exact same process, but for the planks. Because as I also showed you at the start of this video, is that the width of the planks also drive the spacing of the fence. So to show you that again, if I create a curve and if I give it my curve mesh, you can see that it still doesn't really feel natural. So I want to decrease the fence spacing a bit, so the pulls are a little bit closer to each other. This may be a little too extreme, but you see what I'm getting at. So to do that, I'm just gonna repeat the same thing I did here. So I'm just gonna copy these nodes. I'm gonna paste them here. I'm gonna connect them up again. for this one, I'm gonna say plank mesh. I'm gonna get the plank mesh variable. I'm gonna plug it in. But since I'm using the width and not the height, I'm gonna use, instead of the Z component, I'm gonna use the Y component. So what I'm doing is I'm getting the reference of the plank mesh. I'm feeding that into this input. And after that, I'm getting the width of the plank and I'm gonna feed that into this input. So let's hit compile and save and see how that works. Oh, and it's giving me an error because I forgot to plug in my HDI. So there we are. Let's hit compile and save again. Let's test it out. Let's delete the old one. And there you go. So it gave my plank mesh. I don't think it updated my fence spacing actually. And that is because I did not I did not give it the correct tuple name, my bad. So let's compile and save. Let's test it out again. Okay, now it works properly. So yeah, it set the correct parameter values. Awesome. Let's do a little bit of cleaning up because it's starting to get a bit messy. So, but it does work, so that's nice. So I like to collapse everything into functions. Okay, so now it's all cleaned up. We are essentially finished with the first part of the tutorial, which basically just is adding the HDI in the scene and setting its default values. So the next thing we are going to recreate is that when you hit this button in the interface and start clicking in the scene, you can draw out your Houdini curve. So let's get started with that. So I'm gonna open my blueprint again. And we're gonna add a new function. And the function we're gonna add is called onHitByClick. And what this means is basically it gets called the moment I click in my scene. So you can see it also gives us a bit of information. The one we're gonna use is the click pass. So if I break the input device ray, you can see it gives me the rolled ray. And if I break this up again, you can see it gives us the origin and the direction. So what do these values mean? Well, the origin just means the location of the mouse in 3D space, and the direction means the direction the mouse is facing in. So we can use this for a line trace by channel. And what this basically does is casting a ray from the mouse onto the scene. It finds the earliest intersection, and then it returns us the transform information of that intersection, for example. So for the line trace, we need a start position of our ray, so that is just the origin. And we need the end position. So for that, we're gonna grab the direction. I'm gonna multiply it by some high value, like 100,000. I'm gonna add this on top of my original position. And then I can plug this into the end position. So if I hit compile and save, after that I can get my out hit. So if we break this up and click this little arrow, we get all of the information from our mouse ray. And the one we're going to need is the location. And why do we need this one? Well, to create a Houdini curve, we need to feed it an array of transforms, so an array of point locations. So let's just start off by making this array. So let's say Houdini curve points. It's going to be of type transform and it's going to be an array. So I'll just drag this into the scene. I'm going to add an array element. I'm going to get my location. And I'll just like make transform. I'm gonna feed it in here. Also, we have this Boolean value, like the return value. It just returns true if we hit anything to begin with, and it hits false if we didn't hit anything. So I can use this for a branch. So we are only adding points to this array if we hit anything. So let's compile and save. So now we have our array with points. Next up is actually to create a Houdini curve based on those points. So to do that, I'm just going to add a new function. Let's say create Houdini curve. I'm going to link it up after this add node, and I'm going to dive into it. So to create a Houdini curve, if you remember from last time, let's see where, oh, I'm selecting a landscape. There we are. We are using the subnetwork input for that. So the first input should be the curve input, and the second one was the world input with the landscape in it. So just like last time, I'm gonna grab my instance of my HDA, and I'm gonna create an empty input. The input type is curve input. After that, I'm gonna set my input object again. And also, just like last time, I'm gonna say set input at index. And this time the index is 0, and the input is the empty input we just created. But also, just like last time, we need to specify the input object. And this is a little bit different than we did last time, because right now we need to create the input object ourselves. The input object is the curve, so I'm gonna add a new node and say construct object from class. And the class I'm gonna use is Houdini public API curve input object. It's quite a long name. So what this basically is doing is creating an empty curve. Let's clean it up a bit. Now we get a return value, and if we track this, it can say set input or set curve points. And as you can see, it takes an array, and we just so happen to have created this array previously. So if I get my array and plug it in, and plug it in the next node again, for the in object, I can just grab my curve I created from this node and drag it into here. Oh. And I've had compile and save, and I go back into my scene. Let's just delete the old one. Now when I start clicking into my scene, you can see we are starting to draw out a curve. Cool. So to just quickly recap what's happening, I am creating an empty input of type curve. I am creating an empty curve. I am setting my curve points of this empty curve. I am telling Houdini to set this curve as an input object for the empty input we created. And then I'm telling Houdini that this is the first node input, so the one at index 0. So the next thing I want to do, let's just clean it up a bit further. Let's say instance HDA. And this is add or draw curve points. The next thing I want to do is when I click, I'm also adding this little gizmo that I can move around. So I have more control over the outcome of my curve or outcome of my fence. So to do that, I'm not just creating Houdini curve, I'm gonna also, after each time I click, I'm gonna add a TSR or add gizmo. No? create TSR Gizmo. There we are. And it needs a unique identifier for each Gizmo. So I'm just gonna feed it the index of each point it's representing. So I'm adding a point to this array, and this point has its own index, which gets returned from this value right here. And I'm gonna use that as an identifier. It also needs an initial transform. So that's just the transform we just created. And now I can hit compile and save. So now when I click, oh, I need to select my tool, of course. Now when I click, you can see I'm adding a Gizmo. However, you can also see the rotation. You can also see the scale, and these are all things we don't really need. We just need location Gizmo, or the Gizmo for the location. So I can change that with the Gizmo options. So if I track this and I say make Gizmo options, Gizmo mode, I'm just gonna say translation only, and translation elements. I don't need translate Z, I don't need XZ, I don't need YZ. Now if I hit compile and save, and try again, you can see that my Gizmo is much simpler. It only has the information that we need. However, now when I move my Gizmo, nothing happens yet. So that's the next thing we're going to do. So I'm gonna go back to my blueprint. I'm gonna add a new function. And the one I'm going to use is onGizmo transform state change. To just show you what happens is I'm gonna call a print string. And I'm gonna say function called. I'm gonna open my output log. Let's start it in the layout for now. Let's clear it. So when I add some points, and I'm gonna move it, you can see that it gets called twice. The first time is when I grab my Gizmo, and the second time when I release it. However, I only want it to update my Houdini curve points the moment I release it. Like in this final example, you can see my curve point and the Gizmo. It only gets updated after I release the Gizmo. So to make sure that that happens, I can say user branch. And for the condition, I'm gonna say change type equals 1. So what does this do? Well, the change type represents, is like an integer value that is 0 the moment I grab the Gizmo, and it's 1 the moment I release it. So I only want to call this function the moment I release it. So I'm gonna say, oh, if this value equals 1, then update the Houdini value. Cool, so for the next thing I want to do is I'm gonna get my array, the array I created by clicking into the scene. I'm gonna drag a new line, I'm gonna say set array element. For the index, if you remember from last time, the identifier of the Gizmo is the same as the index of the curve point we added. So I can just reuse it. I'm gonna get my Gizmo identifier and drag this into the index. And that's it. Now I updated just the array. So now I can just literally reuse my create Houdini curve node. I drag this in here. Now I can hit compile and save. And now if I go back to my scene, I'm gonna try out my curve again. When I take my Gizmo and release it, oh, I did something wrong, I guess. Okay, it's going back to 0, 0 or something, I guess. Oh, yeah, wait, I forgot to drag in this line. Okay, now it should work. So I forgot to say, oh, the new transform in the set array element. I set it to nothing previously. Okay, let's delete it. Let's try again. Now if I draw out my curve, and if I grab my Gizmo, hold and release, you can see that it updates my Houdini curve. Awesome. One small thing that I would like to do as well, so let's just get rid of the output log as well. In the final example, when I take my curve point, you can see it snaps to the terrain. So let's recreate that for our version as well. To do that, so I'm gonna first clean this up again. I'm gonna say update curve points. I'm gonna grab a new function from this dropdown, and this time I'm gonna say on Gizmo transform changed, and I'm gonna give this a print string again. Let's keep it at hello, it doesn't matter. So this one gets called, okay, maybe I should, this one, okay, doc and layout. This one gets called quite a lot. This one gets called the moment the Gizmo changes its transform, not just when I hold and release it. So we can use that to snap the Gizmo to the terrain. So just like last time, I'm gonna use a line trace by channel. Let's get rid of the print. I'm gonna get the new transformation of my Gizmo. I'm gonna break it. And then I'm going to make a vector. And I'm gonna just give it some highs, that's why like 100,000. I'm gonna add that on top of my original location. And I'm also gonna subtract it from our original location. This is gonna be my start position and this is gonna be my end position. So what's basically happening here is I'm getting the new location of my Gizmo. I am finding where it intersects with the terrain vertically. And I'm gonna use the line trace by channel to find the intersection location. So now I'm gonna get my out hit again. I'm gonna break it again. And now I have my location. Just like last time, I'm also gonna use a branch here to make sure that it has intersected anything to begin with. I'm gonna make a transform again of this location. Oh no, not make transform, just make transform. There we are. And I'm gonna use this for a function called set Gizmo transform. It needs the identifier of the Gizmo, and it so happens that this node also returns the Gizmo identifier. So I'm just gonna grab this and put it in here. I'm gonna clean it up again for a bit. And I'm gonna plug in my transform value. So now when I hit compile and save, and now when I draw out my curve, you can see that my Gizmo snaps to the terrain vertically. Awesome. So I'm also going to give this a little network box to make it more readable. And I'm going to say update Gizmo translation. Cool. So next up, when I add my HDA in the scene and I create my fence, I can change the look of the spline, but I cannot change the parameter values yet. Like when I update these, nothing happens. So let's do that next. Now I can get rid of my output log. And in order to do that, I'm gonna get my property set and I'm gonna call function call watch int property. So what this basically does, it's watching the property of my little interface right here, and it's gonna call an event, or it's gonna fire off the moment it notices that the value or the input value has changed. So I need to do that for every single interface element. So I'm gonna start off with the number of planks. I'm gonna say watch int property. I need to give it the property name. So we know it's called numplanks. And I need to create an event for the unmodified value. So I'm gonna say add event, add custom event. I'm gonna say update planks parameter. So after that, I can, just like last time when I was setting the fence params, I'm gonna set the int parameter of the planks amount. So I'm gonna just copy paste this node. I can drag it in here. It also gives me the new parameter values. So I'm gonna drag it in here. For the target, I still need to give it my HGA, so I'm gonna grab my HGA instance from here and plug it in. Now let's just test it out, compile and save. So let's draw the quick fence to see how it looks. And you can see that now when I change my value, it updates the parameters from the HGA as well. Let's do that for the other ones as well, because those don't work yet. So I'm gonna go back to when I created my parameters. Let's do the flip fence. I'm gonna add another watch. This time I'm gonna use watch bool property. Property set we can get from our variables. Property name was flip fence, if I remember correctly. Yes, it was. I'm gonna add a new event, add custom event. Let's say update flip fence param. I'm gonna, I need to copy my node again. I'm gonna copy my set bool parameter value node. I'm gonna paste it in here. The target is gonna be the HGA, so we can get it from our variables. And the value we can also get from this node. So let's plug it in here, hit compile and save. Let's test it out again. And you can see it worked. Awesome. Okay, so now we can just repeat it for the other ones as well. So for the meshes, so when we update these mesh objects, I need to use the watch object property. So it's looking at the object property and fires off the function the moment it sees it changed. The property set, we can just give it again. The property name was pool mesh. Let's create a new event. Let's say update pool mesh param. I'm gonna go back to my nodes here, and just like if you remember correctly from when we were doing the pool mesh, we were also setting the fence height parameter alongside with it based on the bounds of the pool mesh. So I'm gonna copy paste that as well. So I'm just copy paste these nodes. Let's put them in here. Let's drag this line in here. The property set we don't need. For the HDA, we can just get it from our variables again. Let's plug this in here. And the new value, well, we cannot just drag this in here yet because it's called the watch object property. It does not specify that it's like a static mesh, it just says it's an object. So I'm just going to use a cast to static mesh node before I can plug this value in here again. So I'm just making sure that this return value is a static mesh, and then I can plug it in. So let's clean it up a bit. There we are. Now I can do this once more, but this time for the plank mesh. So I'm gonna use a watch object property again. This time the property name is plank mesh. The property set I can get from my variables. I'm gonna add a new event. I'm gonna say update planks property. And then I'm gonna go back to setFenceParams function, and I can also copy paste these nodes. So there we go. My HDA instance I can get from my variables. So let's plug that in here. Just like last time, I'm gonna cast this to a static mesh again. And then as static mesh, I can plug this into these nodes right here. So let's hit compile and save and test it out. So I'm gonna add a new fence real quick, draw it out. And I can change my number of planks. I can flip my fence. I can change the mesh for the pool. I can change the mesh for the plank. And it all works splendidly. Awesome. Let's delete all the old ones from the scene real quick. Now, also, let's just create a network box for this and say update param values. Okay, so the last thing I want to do is you notice that when I draw my fence in the final tool, and when I hit complete, it automatically bakes down my HGA and it deletes the HGA actor itself. This is something that I like to do because leaving HGAs in your scene, especially in like a production environment, is generally a bad idea. For me, it has caused crashes quite a lot before, but also when you're working in a team, not everyone might have access to like a Houdini license. So for that reason, I like to just bake everything down and destroy the Houdini actor. So to do that, I'm gonna go back to my onScript shutdown node. I'm gonna grab my HDA, the instance. I'm gonna drag a new node. I'm gonna call bake all outputs. And as the name implies, this just bakes the node. After that, I want to delete my HDA. So I'm gonna get my HDA instance again. And I'm gonna call a function called delete instantiated asset. And that's it. So just compile and save. Now when I create a curve and hit complete, it bakes it down and it deletes the asset. Awesome. So I'm just gonna create a new transfer box around this as well. Let's say script shutdown. Awesome. So that's essentially it. That's how the tool works. So that's it. We added all of the functionality to the tool. We can use the spline to change the shape of the fence. We can change the parameters to change the look of the fence, and at the end, if we hit complete on the tool, it bakes it down to a static mesh. So now that everything is done, I would like to give you a few more ideas on how you can use this technology to create other types of tools. For example, one type of tool I like to create is a utility widget. So for this video, I also made a edit utility widget for the exact same tool. So I'll just show you really quickly how this works. I have this little interface. I can add a fence. I can draw up my fence just like this. I can also update my values. I can change my parameters. I can change out the meshes. It does the exact same thing, but this time it's a utility widget. So why might you find this useful? Well, for example, scriptable tools are only introduced in Unreal 5.2, so this is probably the next best solution if you're in an Unreal version earlier than that. It also gives you a little bit more freedom in creating your interface. And another reason why I like this one is because this specific one allows me to work with multiple HGAs in a scene at the same time. As I mentioned last time though, this might be a bad idea. You generally just want to bake and destroy your Houdini assets. But for me, I like this because it allows me to just work with multiple fences at the same time. At the end, I just make sure I bake everything down. But that might be another solution. I'll quickly show you how this works. It's super similar to what we have done in this tutorial thus far. So if I just open this and I go to my graph. So I have like this network box that is meant for instancing HCA. It's bound to this button, the Add Fence button, and it does the exact same thing we've done before. So first, we check if there is a Houdini session. If there is, we're instantiating our Houdini asset. After that, we are binding an event to the pre-instantiation delegate, and I'm using that to set all of my node parameters. After that, I'm binding an event on the post-instantiation delegate, and I'm using that to create my node inputs. This time I'm doing both the world input and the Houdini curve input. After that, I have each of these parameters. I have a function for every single one of them. For example, for the on value change of the blank number. If the value changed, I'm also setting my parameter values again. And also at the end, for the bake, I'm gonna say bake all outputs and delete the instantiated asset like we did last time. It's super similar. Again, you can find this in the files of the Unreal scene. So if you want to learn more about this, you can just download it. I fully commented it out. And I hope you might find this useful as well. So one more idea I would like to give you is that you can use this technology to combine different frameworks. So what you can see on the screen right now is one of my projects. And in this case, I'm combining the blueprints with Unreal PCG. So what you'll notice is when I press the bake button, take some time. But after I bake, it's adding some foliage on the side of the wall, and this is done through PCG. So what I did is I let's open the blueprint. This time it's in the widget again. But what's basically happening is right after I bake, I am deleting my instantiated assets. And I'm grabbing all of the assets I made with Houdini because in Houdini I gave them a tag called isCastleWall. So I'm getting all of my generated meshes. And then after that I can spawn a PCG actor with blueprint. And then I can set the PCG parameters as well through blueprints. And this is super useful because I can drive PCG with blueprints and I can drive Houdini with blueprints as well. So I can just basically combine the two tool sets in one single interface, so to speak. So that is the end of this tutorial. I hope I managed to make your life a little bit easier when working with Houdini assets in Unreal Engine. I also hope you learned a thing or two. That's it for me. Thank you all so much for watching, and bye bye.